Welcome to AI Tele 7. Today we shall discuss the difference between classical physics and quantum physics. Have you ever wondered what's the difference between physics and quantum physics? They sound similar, but they describe completely different worlds. One explains the world you see, the other explains a world so tiny it behaves in ways that feel almost magical.
Physics is one of the most important branches of science that helps us understand how the universe works. It explains the behavior of everything around us, from the motion of a moving car to the force of gravity that pulls objects toward the Earth. Physics, in its traditional or classical form, deals with things that we can see and experience in our everyday lives. It is based on clear laws and principles, making it predictable and logical. For example, when we throw a ball into the air, we can predict that it will rise, slow down, and eventually fall back to the ground due to gravity. Similarly, when we drive a car, we can control its speed and direction using force. These kinds of situations are explained by classical physics, where the outcomes are certain if we know the conditions. In simple terms, physics describes the visible world and follows rules that are easy to understand and observe. However, when scientists started studying extremely small particles, such as atoms and electrons, they discovered that the rules of classical physics no longer worked. This led to the development of quantum physics, also known as quantum mechanics. Quantum physics focuses on the microscopic world, which is far too small to be seen with the naked eye. Unlike classical physics, quantum physics introduces behaviors that seem strange and counterintuitive. In this tiny world, particles do not behave like solid objects. Instead, they can act like both particles and waves. One of the most surprising ideas in quantum physics is that a particle can exist in multiple states or locations at the same time, a concept known as superposition. This is very different from our everyday experience, where an object can only be in one place at a time. Another unusual aspect of quantum physics is that the act of observing a particle can change its behavior. This means that simply measuring or looking at something at the quantum level can affect the outcome. Imagine there's a closed box, and inside it, there's a cat. Now here's where things get strange. According to quantum physics, the cat is both alive and dead at the same time. Not one or the other, but both. This happens because at the quantum level, particles can exist in multiple states at once. But the moment you open the box, everything changes. You only see one reality. The cat becomes either alive or dead. This is called Schrödinger's cat. In addition, it is impossible to know both the exact position and speed of a particle at the same time with complete accuracy. This uncertainty makes quantum physics less predictable compared to classical physics. The key difference between physics and quantum physics lies in the scale and behavior they describe. Physics deals with large, visible objects and follows predictable laws, while quantum physics deals with extremely small particles and involves probabilities and uncertainties. In simple words, physics explains how things behave in the world we can see, whereas quantum physics explains how things behave in a world we cannot see. Despite its strange nature, quantum physics plays a crucial role in modern technology. Many devices we use today, such as smartphones, computers, lasers, and medical imaging machines, rely on principles of quantum physics. Without it, much of today's advanced technology would not exist. In conclusion, both physics and quantum physics are essential for understanding the universe. While physics helps us make sense of everyday phenomena, Quantum physics reveals the hidden and mysterious behavior of the microscopic world. Together, they provide a complete picture of how our universe operates, from the largest galaxies to the smallest particles.